Okay, good evening, students. All hope you all can hear me. Today we are going to discuss some essay and structured essay questions came in past papers from Unit 4 gases. Okay, so we just finished the theory discussion of gaseous state lesson, and we will start this past paper uh, essay structured discussion from gaseous state lesson from 2024 A-level past paper question. Okay, so I'll share that one in the screen. So now let's focus on the question they asked. According to the kinetic molecular theory of gases, for an ideal gas at temperature T, there is an equation PV equal 1/3 mnc square bar. Actually, this equation, we call it as the kinetic molecular equation. Okay. And here P is the pressure of the gas and V is the volume of the gas. M is the mass of a gas particle. Okay, now if you have the tube with you now, please highlight a gas molecule. That part is very important because normally we refer simple M to the total mass. Okay, but here in this equation, simple M represents mass of one molecule. That is important. Okay, so then N is the number of molecules. Understood? So then you can understand easily from the product of simple M and capital N, you will get what? The mass of N number of gas molecules. Okay, so that means the total mass, isn't it? So you can write there simple M into capital N equal total mass. Understood? Total mass. And then C square bar, something we learn under gaseous state speeds, that is called the mean square speed. Okay, mean square speed. It is the square of the CRMS. Okay, so they are asking us to show that C square bar equal 3RT over capital M for an ideal gas. And capital M is the molar mass of the gas. So this derivation, like I said you had in our theory classes, this is very important. So in this year, after a long time, they ask you to derive this equation. Okay, so let's take this as a chance to have a recording of that derivation. So you can refer that part again later also. Okay, you have to start first from by writing those two equations. So first one is PV equal nRT. This is ideal gas equation. Okay, ideal gas equation. And then if you write this one for 1 mole, you can say PVM equal RT, because for 1 mole, N will be equal to 1 and V will be equal to Vm. So like this, N goes to 1 and V goes to Vm, volume of 1 mole. Understood? PVM equal RT. And then you can take our kinetic molecular equation. PV equal 1/3 simple M capital N C square bar. Understood? And this is called kinetic molecular equation. And we use this equation and we get that one again for 1 mole. Understood? So when we take this one for 1 mole, PVM will appear again because molar volume will come. And what will happen to other terms? 1/3. Okay, simple M is the mass of one particle. No? Then if you consider 1 mole, you have to remember this point. In 1 mole, there are Avogadro number of molecule. This point you have to remember. Understood, Lama? It's a very basic and very early thing you learn in chemistry, right? So in 1 mole, you always have Avogadro number of particles. Okay, what is the Avogadro number? 6.022 into 10 to the power 23. Okay, so this number of particles are there. This N is going to be what? Now earlier we wrote the changes that are happening now. So this capital N is going to be changed into Avogadro constant. Now here it is Avogadro number of particles are there. So it is Na. Okay. And then C square bar. Understood that one? Okay. So now we have a very important thing. Here we have the mass of one particle. And here we have Avogadro number. So simply the product of these two will give you what? Simple M into Na. What is this product is giving? Simply you can say mass of 1 mole of particles, 1 mole of molecules. So simply this is what? Mass of 1 mole, no? In other words, we can say molar mass, isn't it? So this is equal to capital M. So then you can write this equation again, or you write this part again. 1/3 capital M C square bar. Understood? 1/3 capital M C square bar. Now we have two equations at the end. Both are equal to PVM, isn't it? So simply we can say first equation, this RT part is equal to 1/3 capital M C square bar. Isn't it? It's a very simple thing. You have to just remember few key points. That's it. Then you can write this very easily. Okay. So then you can say, because 1 equals to 2, you can say RT equals 1/3 capital M C square bar. So therefore, if you subject C square bar, it will give you what? 3 RT over capital M. 3 RT over capital M. Understood that one? That is how you are going to write. That is how I taught you. Understood? So then there is another way of writing this one. So I'm going to show you the marking scheme of the paper. But this is the way, this is the easiest and the most acceptable way you can write. Okay, so I hope you all understood this one. Okay, so look at your note again. You will recall this very easily. See this? PV equal 1/3 simple M capital N C square bar. Okay, so here capital N will be Avogadro number. Okay, so and then we are writing like, okay, now according to this way, what they have written, number of molecules capital N equals moles into Avogadro number. Remember this equation. So I'll tell you exactly how they have taken this equation in the A-level exam. Okay, so we know there is an equation to find moles, the number of molecules divided by Avogadro number. And then this equation tells you capital N equals what? Moles into molar, moles into Avogadro number, isn't it? So according to the A-level marking scheme, what they have done, they have replaced this capital N by moles into Avogadro number. Moles into Avogadro number. Understood, Lam? Moles into Avogadro number. Now look at it again. Moles into Avogadro number. Then whatever the terms you are introducing newly, you have to define them. Understood? So some marks will be given for that too. Okay. And then here you can say simple M into Na. Mass into mass of one particle into Avogadro number gives you molar mass. No? So molar mass into simple N. Now simple N is the number of moles. Now in our derivation, what we did in our board, simple N is missing. Why? Because we consider the derivation for 1 mole. So then this simple N will be 1 in our derivation. Understood? So but in A-level marking scheme, they haven't taken it as 1. So then you have to keep simple N until at the end. Okay, so it doesn't matter, it's fine, because when we get PV equal nRT, it also has N. No? So this N to the other side N get cancelled. Still you will get the same answer. So this method is also correct. And our method is also correct. Okay, our method is not wrong. It's a little bit different. What we did is we assumed or we took it is as 1 mole. So how do we derive this equation again? Just recall once again. You have to use PV equal nRT, ideal gas equation, and the other one is kinetic molecule equation, PV equal 1/3 mnc square bar. Okay. Then in our class, our derivation, what did we do? We assume for 1 mole. Then n becomes 1, n disappears. Okay. And V becomes Vm, molar volume. Okay. Then this equation modified to PVm equal RT. And same thing happens for our kinetic molecule equation. That also modified to PVM. And our capital N becomes Avogadro number. Because in 1 mole, you have Avogadro number of particles. Then Avogadro number into one mass of one particle gives you the molar mass, capital N. Then you put it there. Very simple. Then these two parts are equal. You just say that one and take the subject as C square bar. Understood? So that's how we're going to derive that. Second part. Now, after deriving that equation, usually they are asking you to some question to apply that. See that? A and B are two ideal gases with molar masses in capital M A and M B. Show that the mean square speed of B at the temperature, they have given a value for temperature. Okay, that's sort of an expression that contain capital M A and capital M B is equal to the mean square speed of C gas at 300. Temperature 300 means it is 300 Kelvin. So anyway, we need to derive this one. And we need to just show that. Okay. So how do we are going to do that one? Because now we have the 1/3. Sorry, we have this 3RT over capital M equation. So we can simply apply that one. Apply these data, given data to that one, because you can see C square bar, mean square speed depends on capital T and capital M. Those are the variables. And in this paragraph, they have given values for those variables. For molar masses, there are terms. And for temperatures, there are terms. We just have to show that they are equal. Then let's apply this equation, the one we derived, for the two gases. For A gas, they are asking you to show that this equation, these values are equal. C square bar A equal 3RT C square bar equal 3RT over capital M. So what's the value for the 3R is there? Temperature for A gas is 300 and capital M is capital M A. This is first equation. And then you are applying that one for B gas. For B gas, C square bar B equal 3R you can write. And for temperature, you have to use the given value. 300 into MB over MA divided by capital M B. Then you have to simplify this a little bit further. Okay. So 3R into 300 into capital MB over capital MA, capital MB into capital MA. So this MA comes to the denominator. Then you can see, can MB to MB get cancelled? You can show that one by cutting with a pencil. Okay, use a pencil there. Then what is the final term you are getting? 3R into 300 over capital MA. So now you can see these two endings are equal. Simply, this part is equal to the other part. So you can simply say, therefore, C square bar A equals to C square bar B. That's it. Understood, Lam? It's very easy. It's very easy. I hope it is clear to you all. Right? Shall I show you the marking scheme of this one? Here's the answer. For A gas, you are applying. For B gas, you are applying. Then you say those two are equal. Okay, so that's how they offered 12 marks for that part. Next part of the question, last part. Derive an expression for the ratio between molecular kinetic energies, molar kinetic energies of the two gases A and B at any given temperature T. So here they are asking molar kinetic energies. Molar kinetic energy. So usually this is average molar kinetic energy, and that only depends on absolute temperature. Now here's the important thing. So these two gases, as they tell, exist at the same given temperature T. Then what you can say? Their relationship is what? Their ratio will be, or simply you can say their average kinetic energies will be same, isn't it? Okay, or you can use the equation and show that one. I'll show you what is there in the marking scheme. See, there are two answers. So average kinetic energy is equal to K3O2 RT. That is the average kinetic energy equation. So then that they are applying here. And as the temperatures are equal, their kinetic energies will be equal. This is the way you have to write. If you are writing it as an expression or using set of equations. Or you can simply argue kinetic energy of gases, it should be average, okay? Average kinetic energy of gases depends only on the absolute temperature. Therefore, these two are equal. Still, you get the whole 12 marks. Understood, Lamai? So they offer 12 marks per each, question number 2 and 3, and 20 marks for, 16 marks for the question number, part number 1. Okay, now these are the answers for the part 2 and 3. So please note them down and make a good note. Okay, so the note that you are having with you now, you can add these all answers to that one. Then if you want to revise gaseous lesson again, you have that single tute. You don't have to go and check your bookshelf, and you don't have to refer anything. You have the perfect note with you. Okay, so please add these question reviews to your theory book. Okay, theory note I gave you. And please refer our note and check the derivation on this equation. Remember, average kinetic energy equals 3/2 RT. So in the last question of this essay question, they use this equation. So see how to refer, how to derive this one using our note. Understood, Lama? And then let's go to the structured essay parts. Right, then look at this one, 2023 A-level structured essay question. A closed non-rigid container contains n moles of an ideal gas at the given temperature and pressure. Write the relationship between the number of moles of gas and the volume. Okay, so it's a non-rigid container. Non-rigid container means like a balloon or something. It can change the volume. Okay, so but the temperature and pressure, they are fixed. So you know this thing. If it is an ideal gas, between the four measurable quantities, pressure, volume, temperature, and moles. Okay, these are the four things now. This equation is there, which is ideal gas equation. Okay, and if the temperature is constant, R is anyway a constant, and if the pressure is constant, you can simply say PV equal RT over P times N. So this part is constant, or you can say V equal Kn, or you can say volume is directly proportional to moles. Understood? So all these expressions are showing you the relationship between volume and moles. Understood? So any of them should be acceptable for our answer. Understood that one? So what is this gas law? Avogadro's law. Look at the marking, Lama. First thing, you can write even for PV equal nRT, they gave marks. Okay. Or you can say n directly proportional to capital V. Okay, so they are simply asking the volume and moles relationship. Okay, now look at the second part of the question. So in your tute, the space is given. So please write that one. And it's good to add how many marks that you are getting to. Then look at this. A closed non-rigid container of volume 150 centimeter cube contain 3.75 grams of O2 at a given temperature and pressure. Another 1.25 grams of O2 introduced to this container. That means you are adding newly gas. Okay, so moles are increased. So if they are directly proportional, your volume must also get higher. So they are asking what is the new volume. So it should be a value which is greater than 150 cubic centimeters. Okay, so there are several ways you can do this one. Then in the marking scheme, you can see it's written. If the calculation is done correctly, combining steps, then also award full marks. So how much they are talking about? 20 marks. Okay, so the final answer should be 200. Yeah. And another thing, they have given masses, no? I forgot that. So the masses you need to convert into moles. Okay, but don't try to divide them by 32. Because anyway, both are divided by 32. No? So 32 to 32 get cancelled anyway. Okay, so combining steps you can define this way also. Now, here, to find N1, we need to divide simple M1 by 32. Okay, and simple M2, you have to divide simple M2 divided by 32. Okay, or the molar mass, which is same capital M. You can write capital M also. And then you can say V1 over M1 32. And you can say V2 over M1, sorry, M2 32. Then 32 to 32 cancelled, no? Same, no? Therefore, we can say V1 over M1 equal V2 over M2. Then this is a new derived equation we get from here. Okay. And then we can apply values for this and find the answers. So what are the values it is given? V1 is 150 cubic centimeters. You don't need to convert units. Just keep them for this equation. Huh? But whenever you are using temperature, you must give it in Kelvin. Okay. And I explained the reasons earlier. So refer that. And here it is 3.75 grams. And don't forget the total mass is, you have to add that one. So if you add 3.75 and 1.25, it is 5 grams. Okay, and you are asking for the new volume V2. Okay, so then you can subject V2 and find the answer. So that's what they are expecting. It's a very simple thing. Just figure out the relationships. Okay. So now look at the answer. Yeah, see, alternative answers are also there. Award marks for correct answer obtaining PV equal nRT. Okay, what that means? You can do basically any gas law equation using PV equal nRT also. So how do we do that? Okay, simply write PV equal nRT and apply PV equal nRT 2 times. PV equal nRT from PV equal nRT. Okay, from PV equal nRT, you can say pressure is constant value now. So 150 into 10 to the power minus 6 meter cube equal moles. You have to show 3.75 divided by 32 moles and RT. First equation, and then you are applying the second equation. P V2 then 5.0 over 32 mole into RT. So this is your second equation. So you are dividing second one by the first one. Then V2 you can get an answer. Is that clear? The same way you can do the same equation using PV equal nRT also. This is common for any gas law. You learn several gas laws, Boyle law, Charles law, Avogadro law. So you can do any gas law equation like that. Okay, using PV equal nRT also. Because why? In Boyle's law, you are seeing pressure and volume relationship. When you get that relationship, moles and temperature must be constant. So that means nRT part is constant. Okay, so when you apply Boyle law, you can use P equal nRT too. No problem. So always when the two equations are written, nRT will come. Okay, you can understand same thing is applied for Charles law also, isn't it? So, but it's good to use the original theory. I mean, Boyle, Charles, Avogadro. But if you want, you can go with the PV equal nRT too. You can see in this essay question, structure essay question, they have given marks for that. Okay, so 20 marks. So these are the answers. Okay, Lama. So finish that part. I think you have enough space there in the tute. So write the answer within the tute itself. Okay. Right, and in the end, they're asking us to derive an equation. Derive an equation. So they're asking us to derive an equation for the molar mass. Okay, at constant temperature, no, for the density, sorry. At constant temperature and pressure, show that the molar mass of an ideal gas is directly proportional to its density. Okay, molar mass is directly proportional to its density. Right, so again, you can start with the PV equal nRT. So here they are telling constant temperature and pressure. Constant temperature and pressure. So PV equal nRT. So at constant temperature and pressure. Then you can write PV equals simple M over, so capital M RT. Okay. So simple M over, sorry, V over simple M, then RT over capital M. So this part, V over simple M is what? Density. So the other, other. You can say P capital M to the other side and simple M over V, RT. So simple M over V is density. You can say D or simple D. Simple D. Okay. So then you can write PVM equal, sorry, PM capital M equal density RT. Then if you subject density, P over RT into capital A. Then at constant temperature, if pressure and temperature are constant, you can say D equal Km. So that's the relationship. Density is directly proportional to its molar mass at same temperature and pressure. That's very important. Okay, remember when we do MCQ statement questions, if they say density is directly proportional to molar mass, then if they just say that one, it is wrong. Why? Because density will be directly proportional to molar mass. Okay, only if the temperature and pressure are constant. Okay, so it's very important to give that in the statement question. Right? Now, I hope you understood all about this derivation. Now we'll look at the marking scheme answer. Yeah, or you can simply write proportional thing. Okay, I think there will be an alternative answer. No, it's not given. So anyway, award marks for correct answer obtained using PV equal nRT. So what I did in the board is that. Okay, so you can write this marking scheme answer in your tutor and the one in the board. Both are correct. So next we are going to do 2022 and I saved the best one for the last. Okay, 2021 A level essay question is there. It's a very good essay question, Lama. Okay, so I'm asking my every batch to remember that essay question, the last one. Okay, so wait a few minutes, you're going to do that too. Okay, and learn that properly. Okay, so before that, we will finish 2022 structured part also. Okay, here, look at this. A closed container equipped with a piston contains a mass of an ideal gas at a constant temperature T. Give the relationship between pressure and volume of the gas using a mathematical expression. A closed container equipped with a piston contain a mass of an ideal gas at a constant temperature. So look at that how they are giving it. Okay, so they are asking the PV relationship, and constant temperature is given, and a given mass is also there. So let's highlight that part. Given mass, you can say moles are constant. Okay, and temperature is constant. If you take PV equal nRT, if moles and temperature are constant, you can see nRT is a constant. Simply it will be telling you the Boyle's law, isn't it? Pressure will be inversely proportional to its volume. So they're asking the pressure volume relationship. So simply writing pressure inversely proportional to volume is enough. They're not asking you to derive. So there's nothing to derive actually. If you want to derive that one, this is how you want to write it. Okay. You can say take PV equal nRT. Then say if moles and temperature, say in words, are constant, you can say nRT is a constant. So therefore PV equal K. Okay, if the product of two variables are equal to a constant, then they will be inversely proportional. Or you can write it like this. Understood, Lam? That's how you are going to do it. So I'll show you the marking scheme of that question too. Give me a second. 2022 A level. You just have to say P inversely proportional to 1 over V, or you can say PV equal K. And K you are introducing newly, no? So capital K also, so you can say simple K also, no problem. Whatever you define that, okay? Say it is a constant. That's a good practice. Right. Shall we go to the next part? In the second part, they're asking, show that the density of an ideal gas in one above at constant temperature T is directly proportional to the pressure. Density directly proportional to the pressure. That's what they're asking. So now, above gas sample. So above gas sample means the same one we used for the first relationship. That means the temperature and moles are constant. Temperature and moles are constant. Okay. So you want to show somehow where the density is included to the equation. That's where you need to start. So we derived that, no? Pm equal dRT. So anyway, so just show that one. Simple M over capital M RT. Then Pm equal simple M over VRT. I'm writing the same thing I erased, right? So this is density. P capital M equal density RT. Then what they're asking? Then temperature is, so density is directly proportional to the pressure. Okay. So then you can say for a given gas, capital M is constant. Here temperature is also constant. Say P equal RT over capital M D. So is RT over capital M is constant. RT over capital M is constant. Constant. Because of this. Therefore, you can say P equal K. K is a constant. D. Okay. So in other words, pressure is directly proportional to its density. Or density directly proportional to pressure. That's what they asked, no? Right in the other way. Density directly proportional to pressure. Understood? So this will be only true if the molar mass it is for the same gas and the temperature is constant. Understood, Lamai? So shall I show you the marking scheme of this one? Look at this. There are two alternative answers. Take a screenshot of this one and You can add that both answers. So they start from the Boyle's law, but I did the second part. PV equal nRT starting from there. You have to define every new term. Remember that one. So practice these questions, no? These few questions. I think that will be enough. Okay, see, capital MRT is a constant. So they subjected density. Okay, so but I subjected here P. That's why RT over capital M came. It doesn't matter, okay? You will still get marks, don't worry. But everything we did is correct, no? Can understand. Right, so that's how the second part is done. You'll go to the third part of that question. Show the variation of PV, pressure with volume. In the system 1, the one means the one that applied for the Boyle law. And two different temperatures, 300 Kelvin and 500 Kelvin. So Boyle law simply says the relationship between pressure and volume. But we learned later, these graphs will be, there are graphs for each gas law, and those graphs will be changed according to the these conditions we maintained as constant. Understood? So I'll show you how that is happening. So PV equal nRT. So when in Boyle law we just simply said nRT is a constant. Understood? So if you increase the temperature from 300 to 500, this constant value will get increased. Understood? So pressure volume curve, PV curve, so that's what they asked. Pressure and volume, yes. Pressure volume, there is a curve. There's a curve like this. Okay, so now look at this one. If the pressure is higher, okay, your volume is lower. Volume is low. Let's say this volume as V1. Now I am increasing the temperature. Therefore, this K value get increased. PV equal K, this K get increased. Okay, if I increase the volume. Sorry, if I increase the temperature. Understood? So then if I consider it at the same pressure, same P pressure, P1 pressure, and our new volume should be a higher one. Understood? So this is the, let's say this is V dash, or you can say V2. So volume should be a little bit higher. Why? Because the value of K got increased. Understood? So that means if you try the again this way also, if you take a constant volume, then the new pressure should be a higher value. So then you can understand there will be a curve, a new curve, which is a little bit shifted to the above, shifted upward. Okay. So then this will be the 300 Kelvin curve and this will be the 500 Kelvin curve. So don't memorize everything, try to understand. Okay, so when we increase the temperature, what would happen? The K value or the constant value in Boyle's law get increased. So if you think about the same pressure, so if you have to somehow increase the constant value, so then volume must get increased for the same pressure. And then for the same volume, pressure must get increased. So like that, you can understand this curve shifts upward. Okay, shifts upward. I hope you all understood that one. That's what they are in the marking scheme also. I'll show you how many marks they have given for that. How many marks they have given for that one. Yeah, 10 marks are given. So no part marks, either 1 or either 0 or 10. Understood, Lama? You don't have to mark any other thing. See, it's not drawn to the scale. Just show two curves. That will be enough. So now we discuss 3 questions, 1 essay part and 2 structured essay parts. Okay, so now we are going to go to the most important question discussion in today's class. Okay, so 2021 A-level essay question. So this is the question we're going to discuss. It's a very good one. Okay, now this question is also a very good one. So memorize the method of the question after the discussion. Okay, so we'll see now how to do this question. Okay, see there are 5 parts in the question. First and second parts are kind of really easy. I hope you all did that part. Okay, so look at what they're asking. A gas mixture containing CH4 and C2H6. There are 2 gases. Okay, 2 gases and excess oxygen was introduced into an evacuated closed rigid container. Okay, do we know the volume of the container? Yes, it's given. See, 8.314 into 10 to the power minus 3 meter cube. That's a good thing they did, because whenever we apply P equal nRT, we must convert the volume into meter cube. Okay, for P equal nRT, we must convert the unit. Otherwise, we will not get the answer. So instead of giving it in decimeter cube or centimeter cube or any other random unit, they directly give the unit in meter cube. So here, the student, some students are getting confused and get wrong. Okay, so that unit problem, because of the unit problem, so that will not occur here. They have given the SI unit. That's a good thing, because they want to focus on the structure of the question. That's what they want to see, whether you can do that, not the unit thing. Okay, so look at the next part. The pressure of the container at 400 Kelvin was 4.8 into 10 to the power 6 Pascal. Calculate the total number of moles of gases in the container. Calculate the total number of moles of gases in the container. So what are the things they have given? Volume is given. Temperature is given. Pressure is given. Okay, so we said earlier in P equal nRT equation, there are 4 variables: pressure, volume, temperature, and moles. If you know 3 of them, you can find the other. Okay, so here you know the pressure, volume, and temperature. So you should be able to find the total moles. So very easy. And they are giving you the assumption also. We are assuming whenever we use gas laws for real gases, we need to assume that they are behaving in behave ideally. We learn in our theory class, these gases behave ideally, real gases behave ideally under low pressure and high temperature. So this low pressure means some pressure around 180. Okay. So this, look at the question, what is the pressure they have given? 4.8 into 10 to the power 6. That means a little bit above 180. Basically around like 48 atm, you can say. It's still, you have to assume that they are behaving like ideal gases. Okay, so because they have said it, no? Right. Then there is no reaction between them. They have given that too. Okay, so let's do the first part, and let's see what is the answer we can get. Okay, so you have to say applying ideal gas equation, or you can simply say PV equal nRT. PV equal nRT. So because they will give some marks for the equation too. Later we will check the answers. So we need moles. So I'm going to subject that because it's easy to write in that way. Pressure 4.80 into 10 to the power 6 Pascal. Okay, we can write Newton per square meter. Volume 8.314 into 10 to the power minus 3 meter cube. And R value 8.314. It will be given in the level paper. Joule per mole per Kelvin. And temperature is 400 Kelvin. It is also given in the Kelvin. See, it's very fewer things for you to do. And basically the answer will be 48 division 4, 12.0 moles. Putting a 0 is a good practice, okay, Nama? Because it will show you exactly it is 12 moles. Understood? Then look at the second part. Second part is after the reaction. Okay, look at the question one more time. After the reaction. All the hydrocarbons in the container were completely combusted by increasing the temperature of the container to 800 Kelvin. 800 Kelvin. The pressure of the container after the combustion reaction at 800 Kelvin was 1 into 10 to the power 7 Pascal. Okay, still the volume is same. So they haven't mentioned volume because we know it is constant. Why? It is an evacuated closed rigid container. So highlight that part. That those are important things that you need to understand at the first time you see. Evacuated closed rigid container. That means volume is constant. So same volume will come to the second question too. Understood? Same volume will come to the second question too. Now let's find how many moles will be there after the combustion, after the reaction. Again, we are using PV equal nRT. So we already wrote this part, no? So no need to write that again. Just apply. So 1.0 into 10 to the power 7. 10 to the power 7 Pascal. Same volume. And R value. You must write units, Lamai, okay? For this one. I'll show you later. They will give separate marks for units. Okay, so let's say you don't apply units, you will lose some marks here in the next question and the next one, like that. You continue to lose a small amount of mark, but when it is losing several times, it will become a bigger mark. So it's a kind of a waste. So apply units. If you simplify this, what's going to be the answer? 7 400 over 8. Yeah, 100 divided by 8. So you have 1 here. So 8 for 20, you have 2. 16, 4, you have 5. That's 12.5. 12.5 moles. Now you can see during the combustion, number of moles has increased, no? You have to understand that. See, N total has increased. Remember that point. N total has increased. So how many of you did this part? Got the answers. Look at the marks distribution. So for writing PV equal nRT, you get 5 marks. Okay, and for 400 Kelvin, N1, they are defining N because we are writing N 2 times now. For my answer also, I have to add that. No, that is good. N1 and N2. Or you have to say initial moles, final moles. In words also, it is applicable. And 12.0 moles. And you can see 15 marks are given. And look at the middle one, 4 plus 1. Then plus 1 is given for units. So always write units only. Even when I'm writing in the board, so I've been writing this one for years now. Yeah, think about how much I should be tired of units, but still I'm writing units because I don't want to make a bad example for you, right? You must write units only. You must write unit because you'll be given marks for that. That small mark is still valuable for our Z score. Understood? So final thing of everything we learn, the final outcome should be having a good result. No? Okay, so every mark matters. It's still a 1 mark from 1,000, but still it matters because there are several 1 marks you can see. And the next one also the same, 12.5. Right, now let's go to the interesting part of the question. Interesting and the part that you need to remember. Look at the third part. Write balanced chemical equations giving physical state at 800 Kelvin. Okay, so why they say 800 Kelvin? Because at the combustion, you learned in chemical calculations, during combustion reactions, the carbon goes to carbon dioxide and hydrogen goes to water. So at 800 Kelvin, water will behave like a gas, isn't it? Because it's a temperature above 100 Celsius. No? Understood? 100 Celsius means 373. So here it Kelvin. Here it is 800 Kelvin. So obviously water is a gas. That's why they have said it. So underline this or highlight this 800 Kelvin and write H2O gas. That's why they have given that data. Okay, try to understand. So now let's write the two combustion reactions. This also you can easily do. But this is the beginning of that interesting part. So first equation is for CH4. You must include physical states. They are asking CH4 and O2 reacts to form carbon dioxide gas and 2H2O. That also gas because at 800 Kelvin. 800 Kelvin. Okay, so how many oxygen atoms are there in the right side? 2 and 2. So you need 4 oxygen atoms. That means you need 2 O2. Okay, 2 O2. Then write the next equation. The reaction of C2H6, combustion reaction of C2H6 with oxygen. So like I said again, it says 2 forms 2 carbon dioxide and 3 water. 3 water gas. Now, in this side you have 7 oxygen atoms. But in the right side, how many oxygen atoms are? But in the right side you have, left side you have to add 7 over 2. But keeping fractions is not a good thing. So what did we do at that time? We multiply the whole equation by 2. Okay, so when you are multiplying, then this side will become 7. And in front of this, you have to say 2C2H6. Now check the number of atoms in both sides. Going to be equal, no? And this is also you need to check convert 4 and this is 6. Understood, Lama? These two are the equations. We'll see later. They will give marks for these equations. Okay, writing them balanced and applying physical states. Right, now look at the fourth part of the question. I will then explain why it is so much important and interesting. See, in one of the two hydrocarbons above, contribute to the change in the number of moles of gases before and after combustion. Now we noted earlier, before combustion we had 12 moles. After combustion it is 12.5 moles. So moles are increased by 0.5. So it says here only one gas contribute to that change. That means only one gas contribute to increase the number of moles. Now when we read that statement, we obviously get the idea that we must check the stoichiometries and we must find which gas increasing moles, because there must be other gas is not changing the total moles at all. Okay, so we need to find it. So they're asking, calculate the number of moles of the hydrocarbon initially present of this hydrocarbon initially introduced. Okay, so because why? If we know what is that gas, we know we can find out the number of moles of that one, because we know that is somehow related to 0.5. Okay, the difference of the total moles of initial and final. It is related to this gas. We'll see how to do it. Now look at the two equations. Okay, so in this side you have 3 gas molecules. Okay, and the product side you have what? Again 3 gas molecules. So this one is not the gas that contribute to the increase of number of moles. What is that? This, see, you have 9 gaseous molecules, and by this side you have 10 gaseous molecules. So now number of gaseous atoms are increasing by 1. Understood? Okay, so you need to write by combustion of, by the combustion of 2 moles of C2H6, total moles are increased by 1 mole. Okay, so if the total moles are increased by 0.5, if total moles increased by, now actually it was increased by 0.5 moles, no? 0.5. Okay, we can say moles of C2H6 is not 2 moles, 1 mole. Is that clear now? Okay. So if you have any doubt regarding the the thing I did in the board, please ask again. So we balance the two equations. Then what we do? We check which gas contribute to increase the number of moles. We saw which gas is contributing to increase the number of moles. So it is what? It is the C2H6 gas. Later when we discuss organic chemistry, we will learn what are the names for them. But right now, it is the second gas, C2H6. Okay, 10 gas. And yeah, if you combusted 2 moles, total moles will be increased by 1. See, it got from 9 to 10, increased by 1 mole. But actually, it was increased by 0.5 moles now, right? So therefore, C2H6 should be 1 moles there. 1 mole should be there. Right, now let's check the marking scheme answer. For writing the two equations, you can get 5 marks per each equation. And see, you have write the physical state and should not keep any fractions. Don't keep fractions. And see the way we need to write that fourth answer. Hydrocarbon that contribute to change the number of moles before and after combustion is C2H6. You need to identify the gas. There are 5 marks for that. In my answer also, I showed that one writing number of moles under each equation. Okay, and it's better to apply separate sentence too, like the given one in the marking scheme. And then number of moles increase after combustion is 0.5. The amount of C2H6 introduced initially, therefore 1.0 moles. Okay, so but I think the one I gave you in the board is more clear than this thing, right? So please write that too. Then look at the fifth part. Now we only know how much C2H6 was there. It's not the end. The container then was cooled to 300 Kelvin. Now 300 Kelvin means 27 Celsius. Write it there. 27 Celsius. At 27 Celsius, water is a liquid. And they said it also. Water was removed. Then the pressure of the container was 2.10 into 10 to the power 6. Now another temperature, another pressure. And we know the volume still, no? Volume is constant. It was said at the beginning. And they are asking how many total moles of water was produced. Now, what should we do? Again, one more time, we have to apply PV equal nRT. Isn't it? One more time, we need to apply PV equal nRT. Now, one thing we know for sure, how many moles of C2H6 was there? Okay, we know that one for sure. Okay, now let's apply that equation. Fifth one, part 1. Okay, so PV equal nRT. We can simply say N equal PV over RT. Pressure was 2.10 into 10 to the power 6 Pascal. Volume 8.314 into 10 to the power minus 3 meter cube. This value is 8.314 joule per mole per Kelvin. And temperature was 300 Kelvin. Okay, so how many moles? 21 division 3, 7.0 moles of moles are there remaining. Then This is the remaining moles. So how many moles of water are there? Okay. How many moles of water are there? Therefore, moles of H2O is equal to total minus this value. Total value is 12.5 after the combustion minus 7 moles. So you have 5.5 moles of water. Okay, Lama, understood that one? 5.5 moles of water. 5.5 moles of water. And then the second part, they are asking number of moles of water produced from C2H6. Now, you have C2H6, how many moles are there? You have 1.0 moles now. According to its balanced equation, C2H6, 1 mole gives you, okay, so balanced equation is this now. You don't need to write it again. 2 C2H6 reacts with 7O2 to form 4 carbon dioxide and 6 water. This is what we wrote now. So the water to C2H6 ratio, C2H6 to water, 2 to 6, 1 to 3. That means you can say how many moles were produced from C2H6. So therefore, moles of H2O from C2H6 is 1.0 into 3, 3.0 moles. Understood? 3.0 moles. Then they are asking the third part. Third part is they are asking number of moles of water produced from CH4. So we know one thing. So total CH4 is 5.5. And the water produced from C2H6 is 3 moles. Then the remaining must be produced from CH4. So simply subtract these two values. So 2.5 moles are there. This is the moles of water. See, they have step by step asking this. So we are not going to get lost in the middle. You just have to follow through. Okay. So then now we know the moles of moles of water from CH4. Now write the CH4 balanced equation. It didn't cost to increase the number of moles. CO2 and 2 water. Now if you know how many moles of water were there, you know how many moles of CH4 is there, isn't it? So what's the last question they're asking? Number of moles of O2 initially introduced. Okay, that you have to follow some steps. They haven't given it here. Kind of like a challenge, no? Do the last bit along like that. We'll see. We'll see. Right. So we can find out moles of CH4. Moles of CH4. Because the ratio between CH4 to water is 1:2. Therefore, if you have 2.5 moles, you have to divide that one by 2. So 1.25 moles. Now, how do we find this how do we find this initial moles of O2? Because we know initial total moles are 12.0. Okay, so if I draw the initial container, you have CH4, C2H6 and O2. That's all you have. Understood? So you know the total moles. Total is 12.0. And you know CH4 moles, it is 1.25. C2H6 moles, 1 mole. And then the rest is O2. So go there. Don't try to do other ways, then it will consume most of your time. It's a waste. So the fourth part, you have to start by finding CH4 moles. Then show how many moles of O2. Moles of O2 added is equal to 12.0 minus 1.25 plus 1.0. So it's going to be How many moles? 9.75 moles. With the moles of O2 initially added. Is that clear, Lama? It's a very interesting question, no? What I most likely like in this question is the way they said, they introduced to find the total moles. That's very interesting. They said only one gas contribute to the increase of number of moles, and you can find that gas using the final and initial mole difference. It's a very interesting part. So I'll show you how to do that. See, you are applying PV equal nRT again, you will get another 1 mark for the unit here. So water moles are 7, and then amount of water produced is 5.5. Okay, you get the difference, and water came from C2H4H6 is 3.0. Okay, mark your answers, how many marks you will get. And then the last part, moles from CH4. Then you are finding the CH4 moles. We did it separately. Here they did that one within the questions, no problem. So however, it is 9.75. So 75 marks is the highest mark we see. Okay. So what are the things we discussed now? We discussed 4 essay and structured essay questions. What are they? 2024. What was the question? They asked about C square bar, mean square speed equal 3RTO capital M equation is there. They ask it to derive that equation using a kinetic molecule equation and PV equal nRT, which we did very nicely in the class also, and we saw it, remembered it again. And there was a another method to do the same question in the past paper, it's marking scheme. I asked you to copy down that too. Can remember the both ways, okay? But the one I gave you is the most accurate and most written way. And the next thing, they ask a small question to use the derived equation, and then later they ask an question about average kinetic energy. Then there was an equation for that too, 3 over 2 RT. Then I ask you to revise the derivation of that too. Okay. And then we discussed the 2023 and 22 structured essay questions. Both were asking to derive certain equations. For example, the relationship between pressure and density, and like that. Okay. So look at those derivations in the marking schemes and try to absorb those patterns into your theory. That will be really helpful thing. Okay. And then at the end of 2022 structured essay, they asked to draw a graph for the Boyle's law. And the Boyle's law PV graph is a curve because they are inversely proportional. If one is high, other should be lower. So obviously you will get a curve. And that curve, they're asking what would happen to that one when the temperature is raised. Okay. So then the graph, remember, it shifts upward, but don't just memorize, understand how it is happening. Okay, for the same, but when the temperature increases, the constant value get increased now. So for the same pressure, volume will get increased. For the same volume, pressure will get increased. So that means graph is shifting upward. Okay, so that's the important part there. And finally, we discussed about the 2021 A-level structured essay question. That's very important and very interesting question. Remember the method of that. There were 3 gases, CH4 and C2H6 and excess oxygen. We found out the moles. We had an idea about the moles of one gas with the help of the mass increment, mole increment. Only one gas was responsible to increase the moles, because when we combust CH4, total number of moles are not increasing. 3 molecules are there in the left and 3 molecules are there in the right. But when we go to the C2H6, 9 molecules are there in the left and 10 molecules will be there in the right. That means when we combust 2 moles of C2H6, 1 mole is increasing. So here actually 0.5 moles were increased now. That means 1 mole of C2H6 was there. So after finding that, it was really easy. Understood, Lama? So remember those questions, and it's also that is the exam level. Okay, so for your A-level paper 2027, if they ask gases questions like that, it would be the same pattern. Understood? So practice well. In the next week, like I said, I am going to do the MCQs of past papers one more time with our paper discussion. Okay, right. So I'm going to finish the class for today. I hope you all understood the questions we discussed and go through the tudes again and add these question answers and reviews you wrote now to your theory note, the printed theory note. Okay, that's important because that's the one you are referring when it comes to an exam, right? So see you all again in the next week. Okay, study well. Good night, Lamai.